We have seen that the magnitudes of Ka indicates the strength of an acid. So, when you have higher Ka value, the pH value of the acidic solution will be lower. Same goes to Kb. When you have higher Kb, the basicity of a solution will be higher, meaning to say, higher Kb, lower pOH value, and therefore the pH will be higher. Remember, pOH, when you have the value of pOH, you can minus that with 14 to get the value of pH. Another way of looking into the strength of an acid or a base is through the percentage of ionization. Now, in front of you on your screen is the definition for percentage ionization for an acid, which is defined as the concentration of ionized acids over the initial concentration of the acid times by 100%. So this is the standard definition for percentage of ionization. If the question in exams wants you to write the definition for percentage of ionization of an acid, you should be writing this. If you have degree of ionizations, it will be the same definition, except you're going to be ignoring the times 100%. Same goes for base. Percentage ionization for base is the same as what we have talked about for acids, but instead of writing the ionized acid concentration, you can write it as the concentration of ionized base over the initial concentration of base times 100%. And yes, if you have been asked to write or to work with degree of ionization, the definition will be similar, except that you don't have to write times 100%. Bear in mind that the degree of ionization is the same concept as what we have learned in chemical equilibrium for degree of dissociation. So, if in exams or in any questions regarding to ionic equilibria, if the question asks you about degree of dissociation, or if the question uses degree of dissociation, it's simply referring to the degree of ionization, of which we have talked about just now. So let's have a look at very simple, quick example over here. Typically, when you want to work with degree of dissociation or percentage of ionization, it will be about weak acid and weak base. So when we're working with weak acids and weak bases, we're going to work with the ICE table. So from where do you get the value of the one that we need to write the degree of dissociation? It's simply from here. So remember just now that we talked about the definition for percentage of ionization for acids is the concentration of ionized acids over the initial concentration of the acid. So the concentration of the ionized acids is the same as what we have in here. You can get it from the change. So this is where you're going to get the percentage of ionized acid. Okay? So at equilibrium, so that is how much you're going to get the acid will get ionized to convert into the H3O+. Okay? So you can take the value of X over here, divide by 0.015. So remember that this part of your equation, this is the concentration of the ionized acid. Therefore, the degree of dissociation for this example will be X over 0.015. So another way of writing the percentage of ionization is like this, where you're going to get the concentration of the H plus over the concentration of the acids initially times with 100%, and this one is for the percent ionization for acids, And for base, it's just the concentration of OH minus over a concentration of the base.